What is our remaining carbon budget, say, in Germany? Well, lucky for me as someone who works on this question, I really like to talk about uncertainties. So one of my favorite questions to ask is, okay, so what is the uncertainty surrounding this estimate? Very popular among my peers. So in the next 15 minutes or so, I'd like to take you down the uncertainty lane and in the quest to answer this question of what is our remaining carbon budget. And maybe to start this off, I need to explain what I mean when I talk about the remaining carbon budget. Well, the remaining carbon budget is what explains us how much more CO2 we can emit before we breach a certain temperature target. The concept of the remaining carbon budget comes from a linear response between the CO2-induced temperature change and the sum of all emissions emitted up until this point. And it's true that for any given point in time, the same amount of carbon emissions will cause the same amount of temperature change, at least in the foreseeable future. So just to get this straight, this also means that as long as we emit CO2 to the atmosphere, we will experience climate warming. So what does this linear relationship mean for the carbon budget? Well, now we can say, let's give us a temperature change of, let's say, 1.5 degrees Celsius relative to the pre-industrial time. Now this linear relationship tells us how much CO2 we can actually emit in order to stay below this target. Our best estimate for this linear relationship is that 1,000 gigatons of CO2 emissions will cause a global mean temperature change of 0.45 degrees Celsius. And now for those of you who are fast in calculating their things in their head, that means that our total budget would be 3,300 gigatons of CO2. Now of those 3,300 gigatons, we've already emitted 2,400. So the difference between those two numbers then gives us the remaining carbon budget. That means we're left with 900 gigatons of CO2 globally to emit before we go beyond 1.5 degrees Celsius. Okay, that's our question, right? Thank you very much, but not so fast. What are the uncertainties that surround this estimate? Well, there's different levels of uncertainty that we have to talk about in this context, and I'd like to talk about 3 today. Starting with the Earth system uncertainties. Yay! So that's the Earth. And the Earth's reaction to our anthropogenic experiment. You know, this experiment where we put substances in the atmosphere and they warm and cool the climate. The warming ones are the greenhouse gases, and the cooling ones are aerosols that we put into the atmosphere. Those are little particles that reflect some of the incoming shortwave radiation from the sun and therefore cool the planet. Now, our understanding of the Earth system is incomplete, just because we cannot observe everything at all times. So that means that we have processes in the Earth system that we don't understand. And one of these processes, or one good example of these uncertainties in the Earth system, is the land and the ocean carbon uptake. Currently, about 55% of the emissions that we put into the atmosphere are taken up by the land and the ocean. And now the land carbon uptake is especially interesting because it holds so many uncertainties. So currently what happens is forests profit from the increased atmospheric CO2 concentration. They grow and they take up carbon, and everyone is happy. But with climate change, what happens is that those forests become water stressed more often. So that means that maybe in the future they won't grow that efficiently anymore and take up less of our carbon emissions. Sorry. The same thing, or right on top of that actually, the little microbes in the soil that chew on organic matter and emit CO2 to the atmosphere, well, they become much more efficient when climate change progresses and it becomes warmer. So in the worst case scenario, what could happen is that the land carbon sink can become a source of CO2 in the future. On another note, we know quite well how the Earth reacts to increasing CO2 emissions, because that's what we can observe right now. But there remain much more uncertainties when it comes to a point in time where we actually might reduce CO2 emissions or even go down to zero. So if there is some remaining warming in the system that we've already committed to from past emissions, this might actually come up as soon as we reduce CO2 emissions and then manifest itself during these times. Okay, last point, and I could go on, trust me. I already mentioned those other substances that we put into the atmosphere than CO2. Those are methane, nitrous oxide, those are the greenhouse gases, and then those particles and the aerosols, right? So all of them also impact global mean temperature. And that means we have to take them into account when we talk about the remaining carbon budget. One big difference between all of those other substances and CO2 is that once CO2 is emitted, it stays in the atmosphere for hundreds and thousands of years, so much longer than our human timescales that we're considering right now. The other substances and their effect on the climate are much more dependent on our human short-term choices. And that brings us to the second uncertainty that I want to talk to you about today. The socioeconomic scenario uncertainties. Yay. I'm talking about us humans. So this very complicated term is, it describes our inability to predict the social dynamics or the political dynamics or even future technological developments. And the good story here, the good news here is that as humans, we actually have a big impact on our future climate changes that we'll experience. And as I already said, this is much more important for those non-CO2 greenhouse gases and the aerosols. So that's why I went ahead and I looked at those and I wanted to understand where they come from, where we emit those non-CO2 substances and how they will likely develop in the future. And what I found is that currently our land use and also the agricultural activities emit more of those warming greenhouse gases to the atmosphere than of those cooling aerosols. So just in the non-CO2 sphere of things, that means that they contribute to a climate warming. In contrast to that, all of our activities where we burn fossil fuels and kind of co-emit a lot of those cooling aerosols that are not compensated by a same amount of warming greenhouse gases in the non-CO2 sphere, that means that these fossil fuel activities actually contribute to an overall climate cooling in the non-CO2 sphere. Now, in the future, if we want to achieve net zero CO2 emissions, we will get rid of a lot of those fossil fuel intensive activities. So that means that in the future, we'll lose some of these cooling contributions from these activities and also the warming from the CO2, but we'll also have an additional warming from these losses of the cooling agents. At the same time, agriculture and land use change is projected to stay at the same level as today and maybe even slightly increase in order to comply with the additional demand for energy, for food sources in the future. So that means that the sum of all these non-CO2 substances in the future is likely to contribute to a net non-CO2 warming. And that in turn means then that it will reduce our remaining carbon budget. Okay, are you embracing the uncertainties yet? So, just to summarize real quick, we have this climate metric, and it gives us a carbon budget of about 900 gigatons of CO2. That corresponds to about 22 years of current emissions. Now, the uncertainties in the Earth system, and specifically in the carbon cycle, can add some uncertainties and can add or reduce this estimate by up to 6 years. And when we now consider all these non-CO2 forcing, they may take up to 10 years off the clock. So then we're starting to run out of time. But let's say we know all of this. Natural scientists and socioeconomists come up with one single number of the remaining carbon budget. What do we do then? Well, that brings us to the third uncertainty that I want to talk to you about today, the distribution uncertainty. The remaining carbon budget is a global entity, but climate policy happens on a national, regional, or even subnational level. That means that if we want to answer the question, what is our budget here in Germany, we need to now allocate this global entity to nations. So what is the fair share of our carbon budget here in Germany? Well, that depends on who you ask. Some people might argue that in order to allocate this remaining carbon budget, we should allocate a same amount of carbon to each single person on the planet. That's what we call the equal per capita approach. That would mean that Germany as a nation would get an allocation of the remaining budget based on its share on global population. Some say that's not even enough. We also need to take into account that some nations, and we're talking about the global north here, have contributed much more strongly to the current climate change and the climate crisis than others, namely the global south. So they want to take this historical carbon depth and historical carbon credit into account, and that's the equal cumulative per capita approach. Pragmatists might say, well, let's distribute the budget so that we can keep it, and everyone who can actually tackle this challenge of climate mitigation should get a smaller piece of the cake, because they have the technological or the political means to actually reduce their emissions. And lastly, one argument that is brought on, especially by the developed countries, is to say, well, listen, so we've built all of this fossil fuel intensive infrastructure. So we've committed ourselves to a certain amount of emissions already because we're going to use this infrastructure for the next years. So it's kind of difficult for us to transition to a green economy right away. In contrast, there are other countries that can now leapfrog into this wealthy, carbon-free economy by using these new technologies that we have available. This is, then they ask to allocate the remaining carbon budget based on the shares of today's emissions. Now, which one of those approaches is the more fair or the more realistic? That's a value judgment, and that I will leave up to you. But just one note of caution. Right now, what happens, whether consciously or not, is that nations allocate a larger piece of the cake to themselves than what maybe others would have given them. And at the end of the day, we need to make sure that all of the single pieces of cake come back to just one cake. All right, now that we strolled down uncertainty lane and learned a little bit about the concept of where the carbon budget comes from and the uncertainties surrounding the Earth and us humans, and frankly, what a mess it can be to actually allocate this remaining budget to a nation, I hope that we get a better understanding of why there is so much uncertainty surrounding the remaining carbon budget. Now, when I arrived at the end of this road, I can tell you that I came up with a remaining carbon budget of Germany of 7.8 gigatons of CO2, starting from January 2021. And I also came up with a kind of a trajectory that we would have to keep in order to stay within this budget. And just to give you an idea of the level of ambition that is associated with this trajectory, this decrease of CO2 emissions in this scenario would mean that we would have, emissions-wise, a year like 2020 every second year. Now, currently we're researching how Germany can actually achieve its goal of net zero CO2 emissions by 2050, including some of those options that would allow us to actually take out CO2 of the atmosphere, and all the delicious uncertainties that come with that. And after navigating through this jungle of uncertainties, there is one thing that I can tell you for sure. And that is that we need to transition to a carbon-free, sustainable energy system, and that as soon as possible. Thank you.